Why waste time in commute and spend a lot of money for NEET UG coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. NEET UG. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the PYQ discussions on JEE Advanced papers. Here I have got a problem from JEE Advanced paper 1 2022. The question says, consider an LC circuit with inductance L is equal to 0.1 Henry and capacitance C is equal to 10 to the power minus 3 farad kept on a plane. The area of the circuit is 1 meter square. It is placed in a constant magnetic field of strength B, which is perpendicular to the plane of the circuit. So let us try to understand up to this point from this figure. This is LC circuit, suppose, and this circuit has got area 1 meter square, and this circuit is actually placed in a plane, suppose the plane of the paper, and it is placed in a region where there is a constant magnetic field and the direction of the magnetic field is perpendicular to the plane of the paper or plane of the circuit. Now at time t is equal to 0, the magnetic field strength starts increasing linearly as B is equal to B plus beta t with respect to time. Okay, the magnetic field starts increasing linearly with time. So as this magnetic field starts increasing, the flux link with the circuit will also change, and because of that there will be induced EMF, and that EMF will drive the current in the LC circuit. Here the question is, the maximum magnitude of the current in the circuit is. So as I said, there will be induced EMF. So how to get that induced EMF? Induced EMF will be d phi by dt. Okay, if I take the magnitude, so what is phi here? B into A. Okay, I can write ddt of B plus beta into t whole into A. This is actually the EMF, and this is a constant term. This area is the constant term, therefore I'll get beta into A, and the value of the beta is given here. A is 1 meter square and beta is given this much, so I will get ultimately 0.04 volt. Okay, EMF. Now this EMF will actually drive the current in the circuit, this LC circuit, and therefore this capacitor will get charged. Okay, and let us say the capacitor has got charge Q at t is equal to 0, and the current flows in the circuit is I. Okay, and I have to actually find out the maximum magnitude of the current in the circuit. So to find out that, I have to write down the equation of EMF using Kirchhoff's voltage law or KVL. So if we write that equation, let us see what we get. This is EMF that will be equal to the voltage drop across the capacitor and across the inductor. So this is Q by C, this is equal to 0. Now as I have to find out current, this Q I have to somehow write in terms of current. So simple thing is that if we put the value of EMF 0.04 minus L di dt minus Q by C is equal to 0. Now if I take time derivative of this particular equation 1, then what I get, minus L d 2I by dt square, okay, and here it will be dq by dt divided by C, which will actually give you L d2I by dt square plus 1 over LC di by dt. Okay, if I write this dq by dt as I, that is the current, I by C. So C I have already written, so I. Okay, and this is equal to 0. Okay, if it is making too much, so let us write this equation here. Actually this is identical with the known equation, that is the equation of SHM. Okay, SHM, simple harmonic motions. Okay, this is actually similar to that, and therefore I can write this equation, the solution for this differential equation to be I is equal to I0 sine omega t plus phi. So here we don't know what is I0, what is this phi, whereas we know this omega. Omega I can find out from here, that will be square root of 1 over square root of LC. Okay, now if I apply initial condition at t is equal to 0, current is 0 and also the charge is 0, at t is equal to 0, I'll get total current to be 0 in the circuit, because just then the magnetic field started increasing. So if I apply this, see, we will get actually sine omega t plus phi is equal to 0, which will imply further that phi is equal to 0. Therefore I get this equation, I is equal to I0 sine omega t. Okay, so now I have got this I. If I want to find out what is di dt, can I get that? Answer is yes, I will get that. Di dt is equal to I0 omega, and this will be cos of omega t. Now if I find out this di dt at t is equal to 0, then it will be I0 omega. Okay, cos t is equal to 0, so cos 0 will be 1. Okay, so now look, we had got initially this equation we have got di dt, we have got I as well. So if I want to write di dt here, look, I have got equation EMF minus L di dt minus Q by C. So if I apply at t is equal to 0, Q was also 0, then I can write this as E is equal to this L into di dt. So I have to see, I have to find out the maximum amplitude or the amplitude of the current. So to make it maximum at t is equal to 0, so that is, I 0 omega that we have already got. So we'll just apply it here. So here I have got this much is I0 omega into L, right? From here L di dt will be I0 omega, and this side it is EMF. So I have to actually find out I0, that is the amplitude of the current, EMF divided by omega into L. Okay, so E is 0.04, omega is 1 over root over LC into, this is L. Let us find out the value for this. See, LC will be written here. L is given as 10 to the power minus 1 into capacitor. This capacitance has got value 10 to the power minus 3 farad. Okay, this is again 10 to the power, sorry, this will be in the denominator. I'm sorry. So what I had got, this will be EMF divided by omega into L, right? So this is 0.04, omega is 1 over root over LC, so I am writing LC here, square root of LC, and here it is L. So this is 0.04, this will be 10 to the power minus 1 into 10 to the power minus 3 divided by 10 to the power minus 1 here. Look what I get. So this will be 4 into 10 to the power minus 2. Here there will be minus 2 from the square root, and here I have 10 to the power 1. So this will become 10 to the power minus 3. 4 into 10 to the power minus 3. This is in ampere. Okay. So I get the maximum amplitude of the current will be 4 milliampere. Okay. So 4 milliampere will be the answer for this question. Thank you.
Why waste time in commute and spend a lot of money for IIT JEE coaching? Parents, do you want your kids to achieve top scores in IIT JEE? India's leading online NEET coaching 100% success IIT JEE. At TeenEinstein, we focus on IIT JEE coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.